Welcome to the Explainer. I'm absolutely thrilled to have you with us today. In this Explainer, we're mapping out the ultimate developer's roadmap to mastering modern software engineering tools. Whether you're writing your very first line of code, or you've been building apps for years but never really looked under the hood, stick around. We are going to completely demystify Git and GitHub for you today.
Okay, let's dive into this. We've all been there, right? You save a file as version 2. Then you save it as final. Then, of course, final underscore actually. It's just a universally frustrating pain point of messy, manual file versioning. You inevitably end up with a folder full of so-called final files, and you're absolutely terrified to delete any of them just in case you need to undo a mistake.
So here is our roadmap for today as we level up from a solo developer on a laptop to a global collaborator. First, the version control problem. 2, Git, your local time machine. 3, the 3 states. 4, entering the GitHub stage. 5, the pull request workflow. And finally, 6, how to level up your projects.
Section 1, the version control problem.
You see, older version control systems were what we call delta-based. They simply stored a running list of the specific changes made to each file over time, kind of like a giant receipt of edits. But Git totally reconsidered everything. It actually thinks of its data as a continuous stream of snapshots. Every single time you save your project's state, Git basically takes a picture of what all your files look like at that exact miniature file system moment. If a file hasn't changed, Git doesn't copy it again. It just links back to the previous identical file. It's an incredibly efficient way to work.
Section 2. Git, your local time machine.
Let's bust our very first piece of jargon, the repository, or repo for short. A local repository is really just a normal folder on your machine that's being closely monitored by Git. When you initialize it, Git quietly creates a hidden .git folder inside. That hidden folder is the actual database recording your project's entire history. Honestly, if you were to delete that hidden folder, your project just reverts to being a regular, unmonitored folder again. It's that simple. Next up is the commit. A commit is exactly that snapshot we were just talking about, a permanent record of your project files at a specific moment in time. Think of it like a save point in a video game. And what's absolutely brilliant here is that every time you save your progress, everything is checksummed using a unique 40-character SHA-1 hash. That hash guarantees total integrity, meaning it is mathematically impossible to lose data or change a file without Git immediately detecting it.
And here's a massive perk. Because your repository lives right there on your local disk, nearly every operation in Git is local. You literally have the entire project history right at your fingertips. This gives Git unworldly speed. Picture this, you're on a long airplane ride without a network connection. No problem at all. You can keep coding, testing, and committing to your local copy happily offline and just sync it all up later when you finally get back on Wi-Fi.
Section 3. The 3 states.
Pay super close attention to this part, because visualizing this invisible flow will make everything else click. Git has 3 main states that your code literally moves through. First, you modify a file in your working tree, but Git doesn't just auto-save it. Second, you have to explicitly add those modifications to the staging area. You're basically telling Git, hey, queue this up, I want it in my next snapshot. And third, you commit, permanently storing that staged snapshot into your Git directory.
So how do we actually do that? Consider this table your visual cheat sheet for the command line. These 4 commands will become absolute muscle memory for you. Get init creates the repo. Get add dot stages your modified files. Git commit -m permanently saves that snapshot along with a descriptive message. And whenever you're lost or confused about where your files are in those 3 states, just run git status to see exactly what's modified, staged, or totally untracked.
But wait, hold on a second. Not everything in your folder should actually be tracked. That's where the .gitignore file swoops in. As you code, your project generates temporary system files or massive, heavy folders of downloaded dependencies like node_modules. More importantly, you might have configuration files that contain highly sensitive API keys or passwords. You just list those in your .gitignore file, and Git intentionally ignores them. It keeps your repository perfectly clean and, most importantly, your secrets secure.
Section 4. Entering the GitHub stage.
Let's expand our narrative a bit and clear up the biggest point of confusion for beginners. Git and GitHub. They are not the same thing. Git is the local time machine, the free version control system running quietly on your own computer. GitHub is where we level up to the global internet. It's a remote hosting platform that holds a copy of your Git repository.
It acts as a rock-solid backup and basically a global superhero team-up platform where you can collaborate with anyone, anywhere. Now, to collaborate on that global stage without stepping on each other's toes, we use branches. A branch is just a parallel version of your codebase. Say your teammate is fixing the homepage and you're building a brand new dark mode feature. You each create your own separate branch branching off the primary main project. This gives you a completely safe workspace to experiment, ensuring your shiny new code doesn't conflict with the stable main branch.
Section 5. The pull request workflow.
Now, what's really interesting about this slide is the pull request, or the PR. When you finish coding on your feature branch, you don't just aggressively shove your code into the main project. Instead, you open a pull request. It's a formal proposal to merge your work. This is where the magic really happens. GitHub gives you a visual diff showing the exact lines added or deleted, and creates a dedicated space for your team to review, chat, and discuss the changes before anything becomes permanent.
This entire repeatable loop is famously known as the GitHub flow. It's the exact linear journey developers take to build software together online. You branch locally. You make your changes and commit them. You push those commits up to GitHub. You open that pull request, and once your teammates give you the green light, you hit merge. It seamlessly integrates your local code right into the main remote project.
But what if you find a cool project online, but you don't actually have permission to create a branch there? Let's bust our final piece of jargon, the fork. A fork is a personal, complete copy of someone else's entire repository cloned right into your own GitHub account. It is literally the gateway to open source contributions. You can experiment as much as you want in your fork, and when you've built something great, you just open a pull request from your fork back to the original project.
Section 6. Let's level up your projects. Welcome to the boss level. Once you're comfortable, you'll see that GitHub transforms from a simple storage system into an active, automated assistant. You can use GitHub Actions to automatically test your code every single time you push. You can host a website totally for free directly from your repo using GitHub Pages. You can track all your bugs using Kanban-style boards with issues and projects, and my favorite, Dependabot. It actively scans your code and automatically opens pull requests to update any vulnerable software dependencies for you. It's brilliant.
And speaking of security and automation, I want you to consider this staggering, data-driven surprise. Thanks to AI, GitHub Copilot Autofix can now automatically generate fixes for 90% of security alerts in languages like Java, Python, and JavaScript. Think about that. Application security no longer just means pointing out a problem, it literally means automatically serving developers the exact solution right inside their pull request.
As we draw this explainer to a close, I want to leave you with this fantastic thought from the GitHub blog. Remember, every single developer starts somewhere. Whether you're just putting together a simple portfolio site or you're architecting the next massive enterprise application, these tools exist to empower global learning, secure our supply chains, and build incredible communities.
So now that you know exactly how the local time machine of Git connects seamlessly to the global stage of GitHub, I have a challenge for you. Get out there, open your command line, and ask yourself, what open source project are you going to fork and contribute to today? Thank you so much for joining us on The Explainer, and happy coding.